Hello, everyone. So, my name is Pratim Chatterjee, and today I'm going to take a session on one of the chapters that we have in the syllabus for physics. So, the topic that I'm going to start today is light. So, this is a very interesting topic, and we're going to learn a more or less a brief idea about what is light and what do we have in our syllabus and all that. So let me just start by giving a very brief introduction to light because this is not just a chapter that you will be having in the syllabus. Rather, this is one of the most important concepts that we can have find in physics. The reason behind is that I think all of you know that if we say, talk about physics, let's say physics has these two broader branches, right? So one is classical physics, and the other one is, I think some of you have heard of this. Maybe you have watched it in some of the movies and all. So this is called quantum physics, right? Now, throughout our school lives, we are going to study mostly about the classical physics. Quantum physics is actually, we cannot say that quantum physics is very, very ancient because this branch of physics has been developed in the, let's say, in the early 1910, 1920s, 1940s. So it was the period of the growing, of the vast growth of quantum physics. So classical physics deals with that is the study of the macroscopic universe, the study of the objects that we can see around us, touch and feel around us. But quantum physics, this is a branch of science which deals with the subatomic particles like the electrons, protons, and the neutrons. And the rules of quantum physics are completely different than the rules of classical physics. In fact, Albert Einstein also was shocked in more or less one or two instances when he was studying about quantum physics. Now, why I'm suddenly talking about this classical and the quantum physics is the very jump that we have taken from the classical to the quantum. We can say that this jump has been made possible with one of the most fundamental questions about what is light. So physicists have been wondering about what is the nature of light. Now, I think if I ask you guys what is light, I think many of you will be able to say that light is a form of energy that helps us to see things. True, absolutely, very true. But is there all, or is there can't we go any more deeper than that? So see, when we're talking about the nature of light, this actually made two groups of physicists. In one group, we find physicists who claimed that light is a wave, but there were some groups of physicists who believed that light is actually made up of particles. So hence here was this confusion about whether light is a wave or light is a particle. Now see, something cannot be both a wave and a particle. At least this we can understand from a logical perspective. Let's say suppose there is let's take an analogy. Let's say there is a calm lake or a pond, and you are throwing a pebble in that particular lake or a pond. What will you observe? You will observe circular ripples are being created once you throw a pebble inside in the pond, right? Now, the pebble that you are throwing, you can say that that's a particle. Now, the circular ripples that we'll be seeing, they can be called as the waves. Now, clearly, the ripples are not the same as the pebble, which means that a particle cannot be the same as a wave, or a wave cannot be the same as a particle. So then the question arises that what exactly is light then? So then this was resolved by someone called de Broglie, and he actually said that light is actually both. This was the revolutionary idea, which later also led to the more advancement of quantum physics. Hence, I started with this. But this is not in the syllabus. I mean, don't worry. No one is going to ask you about this right now in class 8 or 9, let's say, about what's the nature of light and all that. But still, this is very important to note because we are studying physics and we must be asking questions and we must be having more or less a briefer idea about what we're studying. So he said that light is both a particle and a wave. Also, just like a coin has two sides, a head and a tail, light also has these two sides, wave and a particle. Now, how light behaves as like a particle or how light behaves like a wave, that's the topic we can discuss for later. So now we know that light is actually both a particle and a wave. Now, if I ask you that, can we see light? This may again seem like a very funny question, but ask yourselves, can we see light? Immediately, some of you may point me to the light in your rooms. Like I can also point that I have light in my room. There's an LED or a tube light, right? But those are actually sources of light. They are not. They are producing light, but they are not exactly the light. A source can never be the same as the object which it produces, right? So and then what can we say? That can we see light or can we see it? Can't we see light? Now, suppose you take instance for how we see things. When we just switch off the light, we get the room is completely dark. We cannot see anything. The moment we turn on the light, everything is visible to us, right? How so? Light falls on the walls of the room and the objects of the room, and it bounces back to our eyes. And inside our eyes, something forms, which is called an image. Okay, so this phenomena, let's say that we are seeing this. Let's say it's the surface, and let's say I'm drawing light right now. How light behaves. So light will fall on this. See, my light in my room is disturbing. I'm talking about light, and my light in my room is actually a bit disturbing. So let me switch off one of the lights. I think it will be doing good. Yeah. So um, yeah. Sorry for the disturbance. Yeah. So see, let's say a ray of light falls on a surface, and it immediately bounces off like this. So just like you are imagining, you are watching a cricket match and you are observing a ball which is hitting the ground and getting bounced to the batsman. So you can clearly see the ball which hits the ground and it bounces towards the batsman, right? Now, can you see anything of that sort which is coming from the tube light or the LED falling on the objects which you can see around you and getting bounced back to your eyes? I don't think you can. So that means that we actually cannot see light, although light helps us to see things. That's a funny irony. But entirely this is not true, because there are some sources of light like the laser, which we can see. But here I'm talking about the light which we are seeing right now in our household light and all that. So that we are not seeing it actually. Okay. Now, obviously, since I've drawn this diagram, I think you may be able to say that let's say this is a normal, and according to one of the laws of reflection, that this is the incident light. You see the incident light, and this light is the reflected light. Right now, one of the law of reflection is that the incident light, the reflected light, and the normal means the perpendicular line drawn from the on the surface, they are in the same plane. This is one of the law. And the other law says that the angle of reflection is equal to the angle of incidence is sorry, the angle of incidence is equal to the angle of reflection. I is equal to R. So what is the angle of incidence over here and what is the angle of reflection? This one is the angle of incidence and this one is the angle of reflection. Okay, now don't get confused with one thing. See, some of you may get confused. Let's see if I draw this thing. This angle which I've drawn, this is not the angle of incidence. And let's say this is the angle which I'm drawing. This is also not the angle of reflection. These two are not the angle of incidence and not the angle of reflections. They are the angles with the surface. Okay, so angle of incidence and the angle of reflection, these angles are with respect to the normal. Okay, so this is very important. This is a very simple but a very important concept. Always keep that in mind. Now, so light bounces off from surfaces and helps us to see things. Now, how are we seeing those things? So we are seeing images. Now I'm coming to this topic about images, image. So we are seeing images of objects. Now, what is an image? How can we define an image? I'll help you with that. So an image can be defined as a point. You can define an image as a point where two light rays meet. Very, very important. Where two light rays meet when after, let's say, reflection or refraction. both these phenomena, which are very important for us, reflection and diffraction. We will talk about refraction some other day. So this is an image, a point where two light rays meet after reflection or reflection. That point where these light rays will be meeting can be called as an image. Okay. Now let us look at a daily example or daily let's say scenario which we all have faced. We face it every day. Let me draw a plane mirror. You all have plane mirrors in your homes, so you'll be knowing what I'm talking about. Let's say I've drawn this plane mirror. All right. Now let me draw two light rays which will be going to incident on this plane mirror. Sorry for that. All right. Now let me draw one more. Yeah. So I have drawn two light rays which are falling on the plane mirror, incident on the plane mirror, and they're reflected by the plane mirror. Let me name them. Let me name them as, let's say this is I1, this is R1, and let's say this is I2, and this is R2. Although I'm not Picasso, but from this diagram, I think you guys can see that these two light rays R1 and R2, they don't seem to meet in the front of the plane mirror, on the left-hand side of this plane mirror. I mean, on the front of the plane mirror, they're not meeting, right? So when we say we are standing in front of the plane mirror and we are seeing these two reflector light rays coming, and they're not meeting each other. So that means no image should form on the plane mirror, right? But when we stand in front of the mirror, we can clearly see our own image and the image of other objects around us, right? So how is that possible? If an image is a point where two reflector light rays meet, then in case of the plane mirrors, the two reflector light rays are not meeting in front of the mirror. Then how is the image getting formed? So for this, you have to understand one thing, that the brain, our brain, is designed in such a manner, it plays a trick on us. What kind of trick it plays? Let's say that whenever two light rays approach us, they approach our eyes and they enter our eyes and they fall on the retina, and on the retina we have a image of that object. But in this case, whenever two light rays are reaching our eyes, our brain makes us into believing that these rays must have met at some point. Okay, so this is a trick played by our brain. These two light rays may never meet in reality, but our brain can make us believe that they are meeting at some point. Now, in this particular case, where can we say that the two light rays are meeting? Let's say that I am extending these two light rays at the back of the mirror. You can see this point? Yeah, we can see this point at the back of the mirror where these two light rays are meeting, or not actually meeting, they're appearing to meet, right? So this point where these two light rays are appearing to meet will be called as an image. But since this is not a real image, this is not happening in reality, this is called a virtual image. So image that we have learned just now, that a point where two light rays meet after reflection or refraction, let me change it a bit. Let me change it by saying where two light rays meet or appear to meet, right? This makes it complete. A point where two light rays actually meet or appear to meet. So that point where two light rays are actually meeting will be called a real image, and that point where two light rays, reflector light rays, are appearing to meet will be called as a virtual image. All right. Now there are, let's say in case of the plane mirror, a plane mirror always produces a virtual image. Okay, a plane mirror can never produce a real image. It always produces a virtual image. But there are some mirrors which can produce both real and virtual images. So those mirrors are called spherical mirrors. Those mirrors are called spherical mirrors, and there are two types of spherical mirrors. One is called a concave mirror, and the other one is called a convex mirror. Now, there is one common with these spherical mirrors and a plane mirror, that is a convex mirror also can never form a real image. A convex mirror also forms a virtual image, just like a plane mirror, always. Now, coming to the concave mirror, a concave mirror can form a real image as well as a virtual image. And they are called spherical mirrors. Why they're called spherical mirrors? Because they're made from a sphere. Okay, let's say the concave mirror. This is how the concave mirror looks like. The concave mirror, it looks like, this is how it looks like. Okay, the inward surface of the mirror is reflecting and the outward surface is rough. But if we talk about the convex mirror, it's just the opposite. The inward surface is rough, but the outward surface is reflecting. You can imagine it like a spoon. Take a spoon, for example. The spoon has two surfaces. One is a bulged out surface and one is an inner surface through which we take the food. Now, the inner surface acts like a concave mirror, while the outer surface acts like a convex mirror. All right. And these mirrors, concave and convex, they have this, they can produce, like the concave produces both real and virtual image, and the convex produces only virtual image. So how do these mirrors produce these images? We have something called Bray diagrams for understanding how do they form the images. So let us take that some other day at some other time. So let me keep this today till here. Hope you guys have enjoyed this. So thank you and goodbye.